share my screen. All right. So yesterday we kind of learned about some of the data types and some of the special objects in JavaScript. We learned how to embed JavaScript in our pages. And today we're going to dive into 3 of the major data types that you're going to use to build every piece of software for the rest of your lives. And those 3 are arrays, strings, and objects. Okay? The first one we're going to take a look at is arrays. And arrays are very powerful, right? They're going to an array lets us store lots and lots of records in a single variable. Okay? So let's take a look real quickly at how to build an array. Right? So here we are. This is our code from yesterday, right? Let's just move all this down. Right, we've learned about declaring variables, right? We say var and then the name of some variable, right? So this would be the name, right? So we're going to say first R, right? We're going to say this is our first array. And the way to declare an array in JavaScript, there's 2 ways, right? The first is kind of the old-fashioned way where you can say new array, right? That's going to create an array. And if we were to type this in here, var first R equals new array, right? You will see that first R is an empty element right here with, you know, a couple of, if we look at the prototype here, we can see that it's got a whole bunch of methods in it, right? Because everything in JavaScript at its core is an object. They have methods, they have functions that we can call on the elements themselves. But arrays are really cool because they let us store lots and lots of records indexed by a number, right? So if we say first R, 0, right? There's nothing in that element. And we can say first R 0 equals hello. Right? And so now if we look at first R, you can see that there is a single element in there at index 0 that says hello. Right? Let's put something else in there. First R 1. Right? So in the second slot, right? Because arrays in JavaScript and in most programming languages start at 0 as their index. Right? They go from 0 on up. Okay? So we'll say first R1 equals world. And so now you can kind of see first R has 2 elements. The first one is an index spot 0 and is hello. And the second one is index spot 1 and says world, right? So we can reference these individually at any time by using the square brackets and putting the number in, right? So first R0 is hello. First R1 is world, right? These are both strings, but our array, right, if we put in another one, let's go into the 2 spot and let's say equals 10, right? Any type of value that we can use in JavaScript can be stored as an element in an array, including other arrays, right? That would be a multi-dimensional array. So if we look at first R2 now, right, that is a number. So we can look at first R, right? Hello world 10. Everyone following along so far? Now, arrays are very powerful because they have all these extra functions built in. And we're going to look at one of these first. One of the first things is not a function, but a property that tells us how many elements are in this array. And that is the .length property. Right, if we type this in, it says there are 3 elements. 3 elements. When we learn about loops later this week, we're going to use arrays as our primary way to go through these. Right, we're going to say, hey, for I equals 0, I is less than first R dot length I plus plus, right? So we're creating an integer that is going to count up and let us go through every element in the array. So we can say, I'll show you an example real quick. For var I equals 0, I is less than first R dot length I plus plus, right? And then we can do console.log first R I, right? Because I, if you remember, is going to be that number we're counting up, right? That's our incrementer counter here. And we're going to console.log first R with square brackets I. So it's going to console.log 0, which is hello, then world, then 10. And if we run this code, right, you'll see hello world 10, exactly like we'd expect. That is the .length property. First R .length tells us how many are in there. Okay? Any questions about .length or the concept of arrays in general? Hopefully this will become even clearer as we continue on looking at some of the methods and properties in here. If we type in first R by itself, all right, the name of the array, right? In this case, it's first R. It's the entire array, right? It's the entirety of the array. All of these index keys, for example, right? We could do first R dot length minus 1, right? Anything that is valid math in here, right, that goes between these square brackets as a number, is going to give us the value that is stored in that position of the array. So if I put in first R4 right now, it's going to return undefined because we do not have a fourth element. Same as 3, right? 3, we do not have a third element. We have 3 items in here, but because it counts up from 0, our highest index is 2. Is everyone tracking? Okay, so we've learned that we can come in here and say, first R3 equals some other value, right? So now we've stored another piece of information in this array. And if we look at first R, now we see that it has 4 elements, hello, world, 10, some other value. What would happen if we assigned a value to an index that was higher than, right? So this is our index, this is our third index right here, some other value. If I was to put 6 in here and say 6th element, right? If we look at first R now, you can see that it created 7 total spots with 2 of them in the middle being empty, right? So the array, when we're using these indexed elements, 0 through whatever, it is preserving the position of the indexes. So if we've created something in the 7th spot, when we, our previous max was 3, it's going to create 4, 5, and then 6, 7, right? So if we did our same loop that we had before, where's that at? Right? This is our loop that is looping through it and printing those all out. Right? It's going to say hello world 10, some other value, undefined, undefined, and then 6th element. Right? First R6 is 6th element. First R5 is undefined. So it's going to automatically expand to fill up the amount of space that we have defined an index for. This is what makes arrays super duper powerful. The variable itself doesn't care how many elements we put in here. We can just keep shoving them on in. Okay. Now, should we be tracking what is our current highest, right? So if we did, first R dot length, right? We know we have 7 elements in here. So our highest possible index is first R dot length minus 1, right? 6. So first R 6, right, is our last place. Should you have to remember that there is something, if I wanted to add a new element here, I shouldn't have to remember the 7th, right? So luckily, JavaScript and most other programming languages, but JavaScript specifically gives us a method in every array that lets us not even care. It just says, whatever the most highest index value is, I want to put this new value at the end of it, right? And so that method is the push method. So if I do first R dot push, and I put in, this is now the highest, right? You put any value you want here. Now it's going to tell you there are now 8 elements. And if we look at first R again, now you can see it. There's 8, and it goes hello world on up down the list. Right now, this is now the highest. That is the push method. And the cool thing is, push works over and over and over again. You don't have to remember number. It's always going to cause the array to grow and tack on whatever you pass in as the argument of the push function to the end of the array, including other data types, right? So it doesn't have to be a string. So I can do first R dot push, 3. First R dot push. I can put in another array. I can say hello world. Right? So you can see here that I'm passing in an array with 2 values, a 0th element and a 2nd element. So let's take a look at that. So first R 12, right? That's our array. And if we look at first R by itself and we use the expandy thing that our console gives us here, it's showing us 0, 1, 2, 3, 4, 5, we're skipped, then it goes to 6, 7, 8, 9, 10, 11, 12. We can expand this one as well, right? And so the way to access multi-dimensional arrays is just keep using the square brackets, right? So first R12 is our array, and then I could put another square bracket in here and say 0, right? So now it's hello, or 1. Now it's world. First R12 is an array, so that gets the exact same functions that the primary array gets, right? So we can do push here and say exclamation point, right? And so now you can see first R12 has hello world exclamation point in it. Everyone following along so far? Any questions? I'm gonna take a drink of water while you think. Go ahead, Creef.
Yeah, I know I missed the part, but how did you get the blank sections?
Okay, yep, good question. So when we have our array here, first R, and it has 13 elements in it. These elements in an array are indexed by a number, right? It's an integer that goes from 0 to however big the array is. So if I look at first R13, for example, right, that's undefined. That's like the next highest spot. So if I was to put something in here like Karif, right? Now the element has 14 total things in it, and the 13th spot is Karif. But because these are indexed by number, and JavaScript is nice to us, right? If I was to come in here and pick a number that's higher, right, like 20, there is no 20th element. There's no, 13 is our highest. But if I type 20 equals, Williams, if we look at first R, right, it is maintaining those index elements already. So an array by default in JavaScript knows that these are integers. It is always going to count up. And so if you put something on an index it doesn't have yet, it has to preserve space for any index or for any element that you may put there in the future. But just because they're empty right now, these are undefined, right? So if we went to, what did I do, 20 there? So if I went to like 18, right? It's going to use the undefined value that we talked about yesterday because it's saying there's a spot here. You just haven't put anything in it yet.
Okay, so it holds the open positions.
Yep.
Got it.
I can come in here and say, Eric, right? So now our array says empty for Eric, empty Williams. It's got to preserve that spot. These have to be integers, right? I can't do first R 1.5, right? Equals something. First R. Now it's turned it into an object, which is something we're going to learn about later today, but it kind of broke things, right? This is not a valid value in here. It has to be, and I think it actually, let's see, first R 21, let's see what that says. 20. Yeah. So it doesn't show up here as a value for us. And if we were to try and loop through it, right, with our function. Where'd it go? There it is. Right. It does not show up because we use 1.5, which is an invalid value, right? It's not a number. So it can't loop through it like this. So arrays specifically in JavaScript, but in every other programming language I've ever used, it always has to be a number. And JavaScript is similar to every other language. You missed this at the beginning, Karif, is that they always start counting from 0. So the first element in an array is at index 0. It goes from 0 to however much your language will let you store, right? So there are upper limits usually, right? So it's like 65 million or something. Any questions with the dot push function? First R, let's make this a new array. First R equals new array. Right, so we're just kind of clearing it out. First R is now empty. First R dot length tells us how many records are in here, right? 0 in this case because it's brand new. And first R dot push, right? We could put any element in here without having to know what the next open spot is, right? So now if we look at first R, it has an element in the 0th spot that has our string that says ASDF. Now, I created this array with the old syntax, new array. Right? We're creating a new array object. This was how it was originally done way back in the 90s. But nobody likes typing this much. So most of the time, what you're going to see is the array literal syntax. Right? It's the term is array literal. And that just means that we can declare a new array just simply by putting square brackets here. Right? It's the exact same as typing new array. Right? It creates an empty array. But what the array literal syntax lets us do is that we can also, just like we were learning with declarations yesterday, we can come in here and say, ASDF, comma, 5, comma, Karif, comma, Eric, right? And we are assigning values to our array as a part of the declaration, right? So now I have created an array with 4 elements in it. The 0th is ASDF, right? If I do first R 0, right? ASDF, 1 is 5, 2 is Karif, 3 is Eric. An array. Arrays are the foundation of just about all of programming. I cannot think of a more useful data type than an array. If you give me a programming language that has an array in it, I can build anything. This is the single most important thing in all of programming is arrays, right? And it's going to translate to almost every programming language you ever use, even if the syntax is a little bit different. So we learned about push. If we wanted to, right, we also can look inside of array. We know there's a Karif value in there. We can say dot index of Karif. And it's going to search in the array and return the index, the spot that word is in, right? So Karif is in our second spot. It's the 3rd element in the array, so it's in the 2nd index, right? Karif is in there. So we could, through searching, say first R square bracket first R dot index of Karif square bracket, and it's going to return. It would return the word, right? So we could use this to search in arrays to see if it exists, right? I could say first R index of Eric, yeah, it found it in there because we're saying this is going to return the index value, and this is going to display the value, right? If I put in something that doesn't exist in our array, right? Apple, it's going to return undefined. It's important to note that first R dot index of, when you put in a word it doesn't have in the array, it returns a -1. -1. Why does it return a -1 instead of a 0 or a null or an undefined?
Would it be because that's where like the next spot it would be in would be at the top of the list?
No. So the problem here is that because arrays start their counting from the 0th index, index of, like ASDF is our first thing in this array, right? If I type in first R, right, you can see that ASDF is here in the 0 position. Index of, if it returned 0, which is generally like what you're going to see as like a false value, if you said, hey, look for a word that's not there, generally most libraries and functions are going to return 0 or false. But 0 is a valid value. So if it returned a 0, that would be lying to us because... and so what they had to do is say -1 means it does not exist in this array. So when we're checking things, right, we're going to learn about Booleans later on. I just want to kind of introduce this concept to you now. When we're searching for things, if I wanted to say, does the word apple exist in this array? If I do if first R dot index of apple, right, and I come in here and say console.log has an apple, right, it's going to return as has an apple because not -1 is a number that is a true value, right? So I could do if -1, right, console.log has an apple. Okay, it's always going to print has an apple. 0 is a false value. So if I say if 0, it's going to never display has an apple. So what we have to do with index of that is unique to this, right? I'm trying to think. I don't think there's any other scenarios where you really have to check the number return here. Is that you have to do if first R dot index of apple does not equal -1, right? So any other value but -1, then it's console.log has an apple. Right? So it's going to return that line of code will never run, right? Because it is not -1. If I was to come in here and say first R dot push apple, okay, now it's in the 5th spot, it will execute because that is not index of is not going to return -1. Index of is a super it's one of those things where you just have to know it's got some quirks to it, right? It's going to return -1 if it doesn't find a value. Index of is also case sensitive, right? So if I type in index of apple, right, gives us a -1 because apple with an uppercase A does not exist in that array. Why would you want to use index of instead of something else, right? So a more traditional approach to this maybe would be to loop through it. Var I equals 0, I is less than first r dot length, I plus plus. And we say if first r I equals apple, right? That's our search term here. We're saying while we loop through this array, if the word here matches the word I'm looking for, console.log as an apple, right? Right. So this is going to show up as has an apple. If I was to change this to uppercase A, right? It's going to be the same as not finding it in the first place. The reason that you would choose to do index of instead of doing this loop is that index of is faster, right? You can imagine we have an array with 1,000,000 elements in here. Looping through each individual element and comparing a value is less efficient than letting the JavaScript engine do that search for us, right? When we use index of apple, even though it's behind the scenes doing the same thing, it's going to probably loop through all of those elements. It's doing it at like the JavaScript engine level, and it's like C++ code doing the searching for us, rather than us looping through it at the JavaScript engine level and having our browser loop through the data object for us. So index of is quite a bit faster than writing a loop and looping through it, generally. And there are a few reasons why you would probably want to do this. Is that if you wanted to check multiple values, or you wanted to do, make it. So here's an example why you would want to do it like this. You can say if first r dot what is the two. Right, you could do some processing in here. What is the str2? I always forget. That's str. Oh, there we go. Why did it say it's not a function? That's weird. Anyway. If you needed to do some processing while you're looping through the array elements, that would be an opportunity for you to do it there. All right, so that's the index of. Right? Index of is going to return the number of the position that it finds it in. Otherwise, it's going to return a -1. -1, I want you to sear it into your head, means could not find it. Because -1 is an invalid, right? If we do first r -1 in here, right? It's going to always give us undefined. That's an invalid value. Go ahead.
For that first conditional statement that you did, where you did the exclamation mark equals -1, or not equals false, couldn't you just do? Couldn't you just put equals 0, so that way it would be like a positive if it does come back?
Index of returns an index, right? So it could be 0. It could be 1. It could be 7. We don't know.
Okay. So
it's going to tell us the index position of it. You can imagine this array has 1,000,000 elements, right? It could be 0. It could be 4,600. So we could. I sometimes see this code written like this, where they'll just say, greater than or equal to 0. Right? That's the same thing as not -1.
Okay.
But -1 is the only value that's going to return if it doesn't find it in the array. So it's generally easier to say not equals -1. So any other value is good. But greater than or equal to 0 also would work. Yeah, good question. Like both lines of code are the same. You'll just get into it's like the advice I gave yesterday, which is like pick a style and stick with it forever so that it always feels correct to you. Like this is muscle memory for me. I'm always going to type it's not equal -1, right? Like I don't even have to think about it. But there's no right or wrong answer. Okay, so just like we learned that first r.push will put something on the end of the array, right? There is a .pop, first r.pop. Right, so let's look at first r first, right? So this is the thing I just put on the end of the array. okay, and it has 6 elements in it. If I do first R dot pop, and I don't pass anything in, it returns whatever was on the end of the array. It's like popping it off of the end, right? But you'll notice now, if we type this in, first R no longer has a sixth, a fifth element, or a sixth element in the 5th position. It has completely taken it off. So push, put something on, pop, take something off. It has changed the array. First R now has this many elements, right? And if I do it again, first R dot pop, it's going to return apple, and it's going to be a 4-element long array. And if I do it again, now it gives me Eric, and it is 3 elements long. So pop is destructive, right? It's going to take that element off the end. This is a useful behavior for arrays, right? A common scenario, if you can imagine that first R, like we were doing a database query or something, and it said, hey, here's the 10 records you were talking about, right? We can write a loop where we say, while, var row equals first R dot pop, right? So as long as there is something to take off the end of the array, console.log row. Right? Right? So it's going to pop off Karif, then it's going to pop off 5, and then it's going to pop off ASDF, but then it can't pop anymore. If we do first R dot pop, right? It returns undefined, and undefined is a falsy value in JavaScript. So us saying, if undefined, right? Console.log, this will never be true. Right? So while there is something to pop off, pop it off, right? So you will use .pop pretty frequently for that type of thing, that type of behavior. It lets us store as much stuff as we want in an array, then we can pop it off at the end. So we will often use this for like first in, first out, or first in, last out queues type of thing, right? So if we said something like, I'll make a new array, var names equals, right, an empty array, and if we do names.push, and we say like in order of who joined the call today, we can say Eric, okay, then we can say names.push, Selena, names.push, other Eric, names.push, and it was like a tie with Josh and Eric, names.push, other Eric, names.push, Karif, and then as we can see from right now what just happened, Karif just left. So names.pop, and Karif is gone. Boom, he's out of the array. He was the last one to enter and the first one to leave. Go ahead, Josh.
Can you push multiple elements at once? So like names.pop, Eric, comma Josh, comma Selena.
I don't actually know. I've never had to do that before. So let's look that up and see if we can. Let's say, what was it? JavaScript array.push. Let's take a look. Yeah. Yep. So we separate them with commas. So if we wanted to say, yep, good question. So we would say names.push, Karif is back, and hopefully at some point in the future, Olivia will join us. Right. So now names has 7. Karif and Olivia. And did you ask also about pop as well? Can you pop off more than one? Doesn't look like you can pop off multiple. Let's just verify. Names.pop 2. Yeah, no, only ever pops off 1. I think it doesn't take any arguments at all. But it's always going to take off. Pop is going to always take off the last element. Push is always going to put, if you put one argument or you put in multiple arguments, is always going to put them at the end and increase the size of your index, right? So it's just a shortcut way of not having to track that number yourself. Otherwise, you can imagine like it would be painful to be like, okay, we've got, names 6. That's Olivia. So we could always do it. I mean, this is how you do it in some languages, like C++ or some of these other ones. You always do names.length, right? Names.length by itself is 7. Right now it says 7. So if we want to put something in the next position, right, we could do names.length equals, some other student. Right? And then we do the same thing. We could say Eric Parker. Right? So push is just a convenient functional shorthand for checking the names.length property, because names.length is always going to say, hey, we got 10 things in here, but because it's indexed from 0 to 9, if you put in names.length, which is 10, 10 is the next number, right? I almost always use push. I almost always use the function push, but it comes down to like syntactical preference, right? Like I prefer to see a dot push because it tells my brain, when I'm in my text editor, right? Like we know that functions have a specific color. So if I was to do var names equals, right, and then I do names dot push, right, it becomes yellow, and so it's easy for me to see that like, hey, I'm calling a function here. I'm doing like this to me reads cleaner than names dot length. Plus, it's more typing, right? Equals Eric 2. And like this is extra letters. It's not always extra letters, but I just prefer it. I prefer the look and feel of it. But they both do the same thing. So that's push. Pop takes one off the end. How would we add one to the beginning, right? We have the ability to do that, right? So we've got our names array. If I wanted to put something before Eric, I could do names dot unshift and put in class. Right? And so now you can see it says we have 10 elements in our array. And if we type in names, you can see that it's at the beginning of this array. So it's going to move everything down to the right, and it's going to give us a new 0th element. That is names.unshift. As a corollary to this, as I'm sure you can imagine this is where we're going, names.shift as a function that will always kind of shift off that first element. So now the 0th element is Eric again, and it has returned class to us. Right? So if I ever needed to take stuff off the front of the queue, off the front of our array here, I can always just keep running names.shift over and over again. Names.shift. Right? And now Selena is in names 0. So if I wanted to have, like in this example where we said, names equals array, names dot push, Eric, Selena, Eric, Josh, right? Like in the order that they came in. If we wanted to have it so that we were building a model that said, whatever order you come in, the first person to come in gets to leave next, right? So then we would use not pop, because that's going to be the last person. Like Josh is the last person to come in. We want to make him stay. He's penalized for showing up 4 minutes late today. So Eric, right? We would use names.shift to have me leave first, then Selena, then Eric, and then finally Josh. So it's operating on the same principle. Pop and push move to the end of the array. Shift and unshift work at the front of the array. And you can mix and match that logic however you want. Now you'll notice that when we were talking about push, I said you could also do names. Names.length is a shorthand for putting something on the end. Right? If we look at names, it should just have Eric now. There is no convenient one-liner like this that lets you put something at the 0th position. Right? If we put in -1 right here, right? Names. Right? It does that same thing where it breaks our array because -1 is an invalid value as a key in our array. And if I do names.pop, it gives us Eric. Names.pop again, it gives us undefined. And now, hopefully, yeah, see, there's still an element in there, but because -1 is an invalid array value, it's completely broken. The only way to fix it would be to come in here and just create a new array. Any questions? Who else? Josh, then it was Eric, then it was Grief, then it was Olivia. for concat and splice and slice, we're gonna go to W3 Schools because they have pretty good examples. W3 Schools. So there are other cool things we can do with our arrays, right? Array.concat. So if we wanted to combine two different arrays, array concat lets us do this very efficiently, right? And so it generally works on this. Well, I'll just write it here, right? So I should have done it. Yeah, perfect. Here, so let's start over from scratch. Clear. I'm going to make an array of teachers, right? Teachers is Eric, Selena, and other Eric, right? And an array of students equals Josh, Olivia, Reef, and Eric, right? If I wanted to create an array that was both of them put together, right? There's a couple, I could loop through it, and I could just, I could write something like for var I equals 0, I is less than students.length I plus plus, right? And I can loop through students and call array, teachers.push, right? Students I. Right? This will it will loop through all the students and push them onto the teachers array. So now teachers has everybody. But there is a nicer and easier method that an array provides us. I can say teachers.concat, right? Concat stands for concatenation. That word means to combine or add together, right? I can say teachers.concat and then pass in students, right? And you'll see when I hit enter, it's doing the exact same thing. It has saved us from having to loop through every element in the array. It combines them nicely in one single line of code. Okay? And now you'll see that teachers, right? Teachers it was not a disruptive change, right? Teachers still has just 3, and students still has just 4, but the output of teachers.concat with students is a brand new array that has all of them, right? So I could do var class equals teachers.concat students. Oh, class is a protected name. Class roster. Right, so if we look at class roster now, class roster is a brand new array. Teachers is still 3, students is still 4, but we've combined them into a brand new array called class roster. You could do it the other way. We could say students.concat teachers. Right? You can also do it with brand new arrays, right? So teachers is here, right? We know that we can do push and we can put in extra words in here, but I could do teachers.concat and I could say, Eric, Karif, Josh, and Olivia, right? So this is a brand new array that I'm creating right in here and passing to concat, which will output Eric, Selena, Eric, Grief, Josh, Olivia. But teachers is still 3. So there are a couple of different ways syntactically to add things to arrays and to manipulate arrays. This is just one of those methods that you can use. Any questions about concat? I need you to remember the word concat because we're going to use it when we learn about strings. It's a very common computer tech terminology to mean like to add one or more things together, to combine. Concat, and it's short for concatenate. Go ahead, Josh.
So for that second to last one, teachers.concat, I understand that you added Eric, Karif, Josh, and Olivia to that. So what's the name of that new array?
There is none because I didn't assign it to anything. Concat is non-disruptive, right? So the teacher's array is still just those 3 elements. What you see here, this little arrow in your thing, is telling us that the return of us running this line of code is this, right? This is what came out of it, this array. But I didn't store it anywhere. It just ran. It's the same as if I came in here and said 5 plus 5. The value is 10. The return of 5 plus 5 is 10, but I didn't put it anywhere. If I was to come in here and say var num equals 5 plus 5, right? Now I'm assigning that And you'll see that the return here is undefined because this line of code didn't return anything. It assigned it. Go ahead, Creed.
I just wanted to just make sure I'm on the right page. So concat just gives you the product of whatever you're trying to concat.
As the return of the function. And we
The
haven't talked
return
really
of the
about
function.
functions that much yet. But what return do is whenever you write a function, we were kind of doing it yesterday. Right? We wrote this function here. It is a value that is returned back to it. Right?
Mhm.
So I could have written this myself, right? This is like native code. I could do like a var, I'll write it the old-fashioned way, function, my concat, right? And I could put in R1, R2. And then I could say return R1.concat R2, right? I could write it like this. I'm returning the value that is being returned from this function itself. So if I was to call my concat is returning those two things, right?
So it's not being recorded at all.
Yeah, it would only be recorded if I came in here and said var my new array equals my concat,
Okay.
R1, R2, or
Okay, I'm following now.
students. Yeah, that's called a return value, and it's whatever the function has said. Hey, I did all those lines of code you want me to do. Here's what the final answer was. And you remember, if we talked yesterday, when we have a function is only called when we include parentheses here, right? Like so, my concat, if I put two parentheses like this, it's calling that function, and if I pass any values into it, it's doing that, and that's what that's what regular concat is doing, right? If I make teachers again, teachers, and I make students again, students, right? Teachers.concat, right? The argument that we're passing to it is another array. So we basically got like if we wrote a function here, let's write my concat and let's do it kind of like how they were doing it behind the scenes, right? My concat takes an array, and it exists within the context of the array, right? So array.prototype, right? So every array object in JavaScript will have my concat now. What it is doing is it's saying for it's making a new array equals array. It's making a brand new array, and then it's saying for var I equals 0, I is less than this dot length, right? Because we are in the array. That's what array. This is like advanced stuff, but just kind of follow along here if you can. I plus plus. Right, so you're looping through the main array. Then you're saying, new array dot push this dot this I. Okay. Then we're saying for the second array, which is the one we pass in here, right? Doing the same thing. For var I equals 0, I is less than r dot length, I plus plus. And we say new array dot push ri. And then at the very end of this, it's saying return new array. So it's taking the existing array that it belongs in, looping through it, putting it in this new array object, this new array that we created up here. Then it's taking the other array that you passed in, and it's putting that in there, and then it's returning the thing. So if I was to let's save this so we don't lose it every time. I'm gonna put this in our script so it will load when we save the file. Okay, students, good. Good. Perfect. Oh, I have a syntax error on line 34. Where's that? 34. Oh. Dot my concat equals function. Perfect. So we've got a teachers array, right? And I just wrote a my concat function that exists for every array because I put it in array.prototype, and we'll learn about that. Don't worry. And it says if I put in students, right, this will return an array that has Eric, Selena, Eric, Josh, but teachers is still preserved. That's what it's doing behind the scenes. Now it probably is written differently, and it's more efficient, probably their version, but essentially we're just doing this. We're taking our current array, combining the new array that we pass in as an argument, and returning that new array without changing. Right? If I had changed if I had changed the original array that we're a part of, right, I can come in here. Let's do this for, let's see, what can we do? We could say new array, or let's say this I equals this I plus teacher. Right? So this would be a destructive array function. Right? This would be a destructive function because it does not preserve. It does not preserve the my concat students. Right? The output array is still being returned as Eric, Selena, Eric, Josh, Olivia. But if we look at teachers right now, each one of those had teachers added to it. Right? Because we said add the current value to teacher. So there are a lot of things like this in JavaScript, and there are a lot of things like this in other programming languages. Pop is a destructive function. It is going to remove an element from the array that it's being called on. Concat is a non-destructive function. Sometimes you'll hear this referred to as functional programming, or where you do not, every function does not change the data that is being passed into it. It always returns a brand new value. Concat is one of those types of examples. Splice. Let's take a look at splice. Any questions with concat before we move on? Okay. It is 4:52. We've got like 2 or 3 more array things to look at. Let's take a 15-minute break. Come back at 5:07. 5:07. Cool. So we learned concat combines 2 arrays in a non-destructive way. Splice. What splice does is it lets us insert elements anywhere we want inside of an array. So let's pull up our example again. All right, so we have teachers, right? Here, let's reload so it's back to normal. Teachers, right? If we wanted to add, let's say, all of the students in between Selena and Eric, right? We could say teachers.splice, and the first argument here is the index to start from, right? So if we said Eric is 0, Selena is 1, we could say start at 1, okay? And then we're going to put in 0, right? This is an optional argument, optional in the sense that, like, if you put something in here, it's going to do something. And then we can come in here and say, and then we pass in an array, right? So we could say students. And what we will have, now, it's in there as an array itself. Let's look at, it's because these are supposed to be not an array. These are supposed to be words put in here, right? So I could put in Eric, Josh, Grief, Olivia, right? So any number of items that we want to add in the middle of this array right here. And if we look at teachers now, you can see that right after Eric, they put in Eric, Josh, Grief, Olivia. No, I should have. Let's reload, make teachers back to normal. Teachers is there, right? I said I wanted it to be after Selena, so I would have to do it at the 2 position, right? So after, right, starting at 2. And so now you can see that if we look at teachers again, teachers now has Selena, Eric, Josh, Karif, Olivia. Everyone tracking? This is a destructive function, right? Because it's changing the original array, right? Teachers has been changed here. It's not doing what concat was doing, where it returns a brand new array to us. Splice is destructive, similarly to pop and push and shift and unshift. It's operating on the array itself. Okay? Everyone followed along there? The second argument here, splice, right? We put in a 0 this time. Let's go 2 again. If I put 4 in here, that's how many items to delete from this position. So it's an easy way for us to swap out elements altogether. So if I wanted to replace Eric, Josh, Karif, and Olivia, all 4 of those, with students, right, with a single element, teachers, it's returning the elements that were taken out. Right, that's the return value of teachers.splice. But if we look at teachers now, you will see that it's Eric, Selena, students, and Eric. Splice is a really quirky one because it does a bunch of different things, right? If we wanted to say teachers.splice and we put the students back in, right, 2, 1, because we just want to remove the word students, and we can put in Eric, Josh, Karif, Olivia. And now you can see that students was the one that was removed. And if we look at teachers, now Eric, Josh, Karif, Olivia are back in. I haven't had to use splice very often in 20 plus years of programming other than to just know that it exists. It's very rare that an opportunity, I can't think of a real world programming scenario where I needed to like swap out chunks of values like this. The only thing I can maybe imagine is if you were doing some kind of ordering, like you had a list that was in a specific order, like shopping list, for example, and you wanted to be able to like drag in, some other list of ingredients, right? Maybe it's like var ingredients. Let's say var shopping list equals an array, and it's maybe got like apple, banana, beef, right? That's our shopping list array. And you're building some kind of app that let you drag ingredients, from like maybe a menu item, and so you have like var ingredients equals cumin, red pepper flakes, something like that. So if I needed to, for some reason, like be able to drag that list of items over here, I could do, I would do something like var shopping list. Shopping list dot splice. Maybe I want it to be between banana and beef, so I would do 2, 0, and then cumin, red, pepper, flakes, right, like that. And so now shopping list has those added to it. That's maybe the only thing I can think of where that would be maybe a reasonable use of splice, but even then.
Push should do the same thing, wouldn't it?
Well, so what splice is doing here is it's putting it in between, right? So if I ever needed to add something to the middle of an array,
got it.
This would be the way to do it, right? It's going to expand the size of shopping list to be 5 elements now. So this is the only way if you wanted to insert stuff in the middle of the array. This is the way to do it safely, right? Because otherwise push would put them at the end. Shopping list dot push, always going to put it at the end. Water. Now shopping list has water at the end, and then unshift would put it at the beginning. Splice is the only way to say put it in the middle, and that's literally what it means. It says splice it, like think of it like a movie where you're splicing together reels of film. You're saying I'm going to splice in this scene right in the middle. That's what this is doing for us. But in practice, in reality, in 20 years of writing software, I don't think I've ever had to splice into an array because most of the time I'm either when we're building real things, most of the time we're putting things at the end or taking things, putting things at the beginning, or removing it all together. Just be aware that if you ever come across a scenario where you have to put something in the middle of the array, splice is the way to do that. And so splice, right? The one downside to splice is that we can't just pass in an array. We have to pass in individual items. So if we wanted to, for whatever reason, just like, always add one thing, if we were writing some kind of loop, I could say, green beans, right? And I could put in, carrots, right? Shopping list is growing at the number 2 position. So green beans went in first, then carrots went in after it. It's pushed it over 1. Another thing you might do with splice is if you said, hey, I don't want green beans to be in there, right? What splice will let us do is if I went to the 4th position and I say I want to replace green beans with baked beans, right? Oh, I took out cumin. Oops. Let's take out green beans, right? So at the 3rd index element, 0, 1, 2, 3, the 3rd index element, we're replacing green beans with baked beans. So this is a good way to like, if you have an array that has a mistake, right? So we could do, check this out. Shopping list dot index of baked beans, right? is in the third. The first one is in the third position. We made a mistake, right? Because we put in baked beans and plate. Oh, let's do this. Right? If we look at shopping list, right, we put in baked beans twice, but I want cumin to be in there. So what I can do is I can say index of baked beans, and I can use this value. It returns 3 when I call index of. I can say shopping list dot splice. Shopping list dot index of baked beans. Put in 1 because I want to swap out one element with cumin. Cumin was the one I needed to be in there. And so baked beans was taken out, and shopping list now has cumin where green beans was before. So this is, if you're doing some kind of search or find and replace would be a good use of splice like this. And when we get to strings, splice will be used there as well. And so I have used splice quite a bit with strings. But if for whatever reason you're ever building some kind of thing that needs you to be able to swap out words, right, or swap out values, splice will let you search inside that array, find the index where that exists, and then replace that with a single element, right? Or multiple elements, right? We could replace all of baked beans. Now baked beans is in the 4th position. So if we did shopping list.index of, it's going to return 4. But if I could say baked beans is the last thing I need to buy from this shopping list, I could put in, 6. Oh, I took out too many things. Oh well. I would have had to have picked out, so cumin is gone now. And now index. Yeah, perfect. So it's just a tool to be aware of. If you need to swap out something from the middle or you need to insert something into the middle, splice is the way you do it. Pop and push, pop and unshift, put it either at the end or the beginning respectively. Then there's also the slice command. Slice is kind of similar to splice. Let's search on W3 Schools and see what it has to do. Array.slice. Okay. Slice is kind of like, slice is kind of like spice, except it does not cut it out of the array. It does not change the original array. This is a non-destructive kind of version of splice, right? And so the way we use this is I could say, got our shopping list here, right? If I wanted to find out what was, slice from the 1st position to the 3rd position, banana and carrots, right? This is the 1st index. This is the 2nd index, and it does not, it says up to the 3rd index, right? That's cumin. Right? If I wanted to get banana, carrots, and cumin, I could do 1, 4. I can also ignore the 2nd argument altogether, and it's going to give me everything up until the end. Right? So we know, for example, that, but this is also non-destructive, right? Shopping list is apple, banana, carrots, cumin, cumin. So if we wanted to build like unshift, right? We know that unshift puts something at the beginning of the array, right? What I could do is I could write a prototype dot my unshift, right, equals function, and let's put in a value. I could say something like this. I could say var. It would probably be easier to use concat. So that's a silly example. What would slice be useful for? Slice is good when you need to get a subset of your records, right? And so if you know, hey, I just want the last 2, right? You could do a shopping list dot length, which is going to give us, in this case 5, right? But I want to get the last 2 elements in there. I could do shopping list dot length minus 2, and it's going to give me cumin, or I could do 3, and 3, and it's going to give me carrots, cumin. Or I could say shopping list dot length minus 1, right? Carrots, cumin, because we're saying go up until this spot. So the dot length property is really useful for letting us dynamically play with our arrays in interesting ways. because slice is non-destructive. Shopping list, right? If I wanted to get the last element off of this array, right, I could do dot pop, which is going to give me that value, but also permanently change shopping list. Or I could do, give me shopping list dot slice, shopping list dot length -1. Okay? It's going to give me cumin. But shopping list still has cumin. I haven't taken it off of there. Or if I wanted the last 2, I can do it with this, right? 2. Because, I could have also done shopping list, right? Shopping list dot length -1, right? Accessing that property altogether. This is giving me the value at that spot, shopping list dot length, but it's not an array, right? And it doesn't give me the ability to, right? This is returning an array to us in a 0th position. And it does not give us the ability, if we were trying to do it with the array literal version, I don't have the ability to get 2 values like I can with shopping list -2 or shopping list -3. Shopping list dot length -4. So slice gives us a lot of flexibility in how we access the values in our array. Gives us some mathematical, when we're talking about simple mathematics here, right? We're saying, whatever the length of the array is, we know that that's like the next spot we're going to insert something into, right? If there's 5 elements in this array, right? It's 5 long. 5 is our next index that we're going to use if we do a push. We can do simple math to go backwards from the end of the array. Any questions about that? Okay. We kind of talked about multidimensional arrays a little bit, but what this is a more common thing that you should get very comfortable working with, right? So let's define ourselves an array, and I'm gonna do it in here so that it's a little easier for us to see and hopefully visualize. Var multi-dimensional, multi-dim. We'll call it that. And I'm going to use the literal syntax, right? So we know that I can comma separate values in here. I can say Eric, Selena, other Eric, right? Every element between our square brackets, when we're assigning an array like this, is a separate index, right? So this is 0, this is 1, this is 2, right? But a multidimensional array says that I can have an entire array as one of these elements, right? So I'm going to make another one in here. I'm going to say Eric, right? I'm going to say Karif, Olivia, Josh, right? This is multidimensional. And if I was to look at multi-dim, right, you can see that it's Eric, Selena, Eric, and then another array with 4 in it. If we expand this out, right, we can see that this array is another array that starts at 0, right? So we can, how would we access this, right? And the way we do it is with that same square bracket version, right? So multi-dim 0 is Eric. Multi-dim 3 is the other array. So I can just chain these together. I can say, well, who is, number 2? That's Olivia. Multi-dim 3, 2. There is no limit, no practical limit, to how many dimensions we can put in here, right? We can say multi-dim 3, which is our array, right? Dot push, and I'm going to put another array in here. I'm going to say, like, hi, there. Okay. And if we look at multi-dim 3, right? Now we see that in the 4th index, the fifth total element is another array, right? So if I do, 4, that's our array, and I can do 1. That's the word there. Complex data structures, complex programs that we're going to build are going to use multi-dimensional arrays all the time, right? And a great example of this, and this is kind of like a sneak preview of where we're going, is that if you think about it as like a spreadsheet or the more realistic view, what we're going to have when we learn about databases is we're going to get records returned back to us. So we'll have an array that is something like DB records, right? And each record is going to be like Eric, Harrison, admin, right? Like one row from this database. Think of it like an Excel spreadsheet where each row has multiple columns in it, right? And so it'll be like Eric Harrison admin, then it'll be like Selena, Eccles. Oh, forgot my Eccles. TA. And then Eric Starling's TA, right? On and on down the list, so that we can have an array. Like, this is exactly the type of data structure that will be returned to us from databases, right? When we make a query, we say, give me a list of all of the students and faculty and teachers. It's going to come back with this kind of structure. So it's an array filled with arrays. Okay. And so if we look at, DB records, right? DB record 0 is my record. DB records 1 is Selena's. DB records 2 is other Eric. On and on down the list. You're going to see and use multi-dimensional arrays for the next, hopefully 40 or 50 years that you're doing this professionally. This is a core concept. Multi-dimensional arrays. And it's often going to look very similar, more realistically, kind of like this. Like this kind of structure. Go ahead, Josh.
So wouldn't something like that, like a multi-dimensional array, I would envision that more being on the back end, because it seems more like kind of what with your example, more like database type stuff.
Mm-hmm.
So would you use it on the front end, or
Yes.
I guess I'm having a hard time seeing where that would be on the front end.
Yeah, so that's a great question, and we will definitely cover real world examples of that this week. But imagine, if you will, that our backend server is generating this type of code, okay? And we're sending this code to our browser on the front end. One of the reasons we use JavaScript on the back end in this class is that it translates over very nicely, so that the code is pretty much the same in both places. Right? We're going to write code that returns us through an API a record that looks like this, and this is called JSON. Right? So this might be a JSON encoded record. And if we go to, we'll learn about this week. If we look at the DB records, right? Dot it's JSON dot encode, JSON dot stringify DB records, right? So you're going to get the server sending you a value like this on the back end, and we're going to capture it on the front end and say, JSON.parse, right? Turn this string into a JavaScript object that we can then use. And what we'll end up doing with this kind of information is let's make a table in here. Maybe let's do a UL. Say ID equals users. Okay. We'll have a UL in here, and we'll simply come in here and say, for var I equals 0, I is less than db records dot length I plus plus. And then what we'll say is, var row equals, let's make it better names. Var user equals db records I, right? So we're looping through each one of these individually. And we're going to simply say, document.getElement by ID. What did I call it? Users? Yeah, users. Oh, excuse me. Let's do this the easy, cheap way. Right? We'll say, so we're looping through each record, and we'll say, I'll make a string. Var list equals, right, empty string. And what I'm going to do is every time I loop through this array, I'm going to say list equals list plus li plus user 0, that's the first name, plus space, plus user last name, plus space, and then I'm going to make a strong tag and say plus user 3, user 2. Right, that's our permission. And then close out the strong and close out the li. Okay? So I'm building like HTML in here, and this is like the ugly way to do it. We'll learn better ways, but this is the quickest. And then at the end of this, I will simply come in here and say document.getElement by ID users.innerHTML equals list. Right, so I've made some HTML. I'm looping through these records coming from the database, and I'm displaying it on the screen. /li. There we go. Perfect. So now we've got each user put in here. You're going to have to operate with arrays whether you're working primarily on the front end or whether you're working on the back end, because that's the data format that's going to come to you from the server. And array is just one of those examples. We're going to learn about objects today, which is probably a more realistic way these are going to come to us. But almost always, right? We haven't learned about objects yet. Well, we have. The DB record itself, because arrays can contain any data type, right, will probably look more like this, right, where each element is an object. Well, I'll just take this out so that I can type quicker. And I'll say, first name is Eric, last name is Harrison, role, right? And then we'll have multiple records in here that match that format, right? Meg and Isla, right? Summer, student, right? And so instead of being an indexed thing like this, it would be user dot first, user dot last, and user dot role. Right? Same sort of principle. This is a more reasonable, like most of our code coming from the back end or coming from the database will use this type of format because it's just way easier to remember. The dot first name is this, the dot last name is this, rather than having to use indexed items, right? Indexed items, indexed arrays, like a traditional array, is a more traditional way of doing things for, like, if you think of it like in terms of, this is a list of things that goes from 0 to 100, like an ordered list, for example, right? Like a traditional array suits itself well for that kind of thing. Database records, database results are traditionally shown as a traditional array like this, because record 0 is your first result, record 1 is your second result, record 2 is your third result, on down that list. So the array generally holds, whether it's holding an object or a bunch of strings, you just have to be aware that it's what an array is, because you're going to see it everywhere. Any questions? That was a good one, though. And I think a lot of that will make way more sense to you as we progress a little bit further on in the course, and as we start learning the back end stuff. You'll notice that, like, whether you're writing JavaScript on the back end and continuing with Node.js, or you're using a different language like PHP or Ruby on Rails or Python, any other programming language, you're still going to have to be able to operate on some concept of an array or some concept of an object or some concept of a string that the server is providing. Whether it's through an API, or you just need to be able to, like, loop through an array of elements, right? If we did document.getElements by class name, I don't think I have any, here, let's do this, by selector, and we'll learn about these functions this week as well, by selector, and we say li, right, get elements by, what is the query selector all, that's what it is, query selector all, right? That is giving us, it's showing up here as a node list, but this is an array, right? 0, 1, 2. That's fetching all of the LIs that exist in this page. So even from a front-end perspective, you have to be able to know that I can come in here and say, what is the first LI, right? This one. That's then the first index. The 0th index is the first LI on the page. And if I hover over it, you can see that it highlights that top one. And so if I was to operate on this, like a lot of these browser-specific or front-end specific elements, like the 0th element here is an HTML element, right? So that has all of the things that dot style, dot background color, right? It is an object. It is a fully formed thing being returned to us in a format that is like an array. Let me say equals purple. All right, let's talk more about strings because strings are super duper cool. We've been using strings really since we started playing with JavaScript last week. A string is any combination of letters put together in a variable, right? So we can say var my name equals Eric, right? This is a string. But what it's important to note is that behind the scenes, in every programming language that I know of, at like the computer level, a string is really just an array of characters, right? So my name 0 is the letter E. My name 1 is the letter R. My name 4 is nothing because we index from 0, right? So my name 3 is C. My name, which is a string, and if we do type of my name, it returns string. But what that also means is that we have some of those same functions that we had available to us on the array level that are available to us on the string level. So my name dot length, for example, says 4. Can we put something in B? Let's look at my name now. So one slight difference is that with strings, we cannot create new values with indexes, right? In JavaScript specifically. I can't say my name 5 equals L, right? My name is still just Eric. There is also no push function, right? If I type this, my name.push is not a function. So it is technically an array, but it has slightly different functions available to it. So one of the ways, we learned that with an array, when we wanted to combine them together, we would use what's called concat, right? Concatenation. So my name dot concat is also an option, right? So I can put in Eric Harrison, and now it is returning this new value. Just like with arrays, it did not change the original version of the string. It is preserving the variable, the string that was in my name. When I used concat on this, the concat method is just creating a brand new string and returning it, right? So if I said var full name equals my name dot concat Ryan Harrison, full name now contains Eric Ryan Harrison, but my name still just has Eric. Now, there's some beautiful, like almost never will I use my name.concat. And the reason for that is because JavaScript has provided us with some beautiful syntax that makes it really easy to get ourselves in trouble, but it's also very easy to combine strings. And that is by using the plus sign, right? So if I wanted to also concat without having to use my name.whatever, right? So I can do my name plus, and then I can put in a new string. We can combine strings together. We can concatenate strings just by using the plus sign. So I can say Ryan Harrison, right? And it's doing the same thing. But you'll also notice that this model does not mess with the first string either. Concatenation can either be a plus sign or you can use the concat function. Almost always, I use the plus sign. And you've been seeing it like when I was building this list. I'm saying li plus the user.first plus the plus a space plus user.last plus some HTML. This is using string concatenation. I could have written this as list equals list dot concat li, right, and then add that full string on in there. Right, this would be combining all that together, but that would look really ugly. So in JavaScript, most of the time you're going to see this form of string combination as the primary form. Okay. Now this is kind of like the warning sign, and why I say this is a little bit risky sometimes, is that this is what gets us in trouble when we're working with numbers and strings at the same time, right? So if I have var my name equals Eric, right, and I have var age equals 27, right? If I do my name plus age, right, it turns the number into a string and it concatenates them together, right? That's what it's doing. Eric 27. This is now a number, right? And that works the same when you concatenate a string with any other data type, it assumes that you're trying to convert that to a string. Regardless, string takes precedence over everything. So like if I had an array, and we have teachers, right? If I do my name plus teachers, it is doing the toString function, right? Teachers dot toString, right? Which converts it nicely into a comma separated list, and it's combining it automatically to my name. So you see it says Eric, but there's no space in there. Same with if we had an object. Do we have any objects? Let's make one var. Well, we have a function, right? What do we call this? We have a function here. Yeah, EL, right? We have an EL function that we wrote yesterday. The EL.toString function is the actual string of the code, right? So if I was to do my name plus EL, right? It's combining the toString of that function to my name. Like, so concatenation of strings always turns whatever you're trying to concatenate into a string. Everyone kind of tracking that? That's string concatenation. But it is extremely useful, and you will combine strings all the time. And a great example of that is exactly this. Look, this is not the best way to do this anymore. There are better ways to like write code that uses stuff like this. And we're gonna, when we start learning about the document object model, like probably the better way to even do this would be to do, var l equals document dot create element li, right, and then say li, el dot inner HTML equals user dot first plus user dot last, and then to simply say document dot get element by ID users dot append child el, right? So that we're not building these nasty, ugly strings of HTML in our code. Right? This is like the more correct way, probably, to write this kind of code. But we'll learn about that. We'll learn about that later. You will see this pretty often in combining strings, like in this type of pattern where it says like the first name and the last name need to be combined together. You'll see this type of code all the time, where it's like first name plus, and then you add a little space in here so that there's a separation between the words. Last name. This is just concatenating 3 separate strings. Okay. When we were looking at the el.toString function, right, you'll notice something special in here, right? These are special characters. A /r and a /n are special characters, and I'm sure you can guess what they do. This is a carriage return and a new line combined together. Because in my code, when we look at the el, right, I hit enter and I hit enter, right? I hit enter twice. This is what our code looked like when we loaded this page. If I took this out, right, so now it's just 1, and I do toString on that, it's just showing 1 carriage return new line. This is Windows specific, so this is going to be specific to me. The Windows specific way, whenever you hit the enter key or the return key in a text editor, Windows is putting a carriage return, which is like old-fashioned lingo from like when we used to use typewriters, and a new line, which is like the new and improved way. Windows said, we need to be backwards compatible with all these old machines, so we're going to use both of them to represent one single line being added to our text editor. On a Mac, this might just be a single new line. If you're on Unix, it might just be a single new line. I think Windows is the only one that's uses both, but I'd have to. It's been years since I looked at that. But this means when we're inside of a string, this would be the way we can add special characters, special things like this, right? And so maybe an example of this would be, let's say, right, var complicated string equals. Here, let's add a text area in here. Text area ID equals text area for format. Right? I'm just grabbing myself a place to put information in my text area. Oop, got a closing tag. Perfect. So if I was to come in here and say, I'm making myself a, like this is a string in JavaScript. Hello world I want this string to have new lines, right? If I was to come in here and say document.getElement by ID, text area for formatting, dot inner HTML equals complicated string. When I type this in the text area, right, the text area doesn't, like, if I wanted to have the new lines included in this string, I can provide them by putting in a /n, right? And so now you can see I have created a new line between this and the string. We also have the ability, if I wanted to, this is another escape character, right? So any character we want to escape, we looked at this yesterday. If I wanted there to be a double quote in here, I'm going to use the / to escape it. Otherwise, it would, let's make this bigger so we don't have to keep, let's look at it. Where are we at here? Rows equals 10, calls equals 10. Good. Is that big enough? Oh, geez. Calls equals 40. There we go. So you'll see that whatever we put into that text area is completely, the white space is preserved, right? So there's, the problem here is we've got a / here in our JavaScript here. Oh, I put it in there right there. Right? So every single bit of white space that we put in here is included in our text area. Right? This is one of the few places in HTML. There's one other one that has this by default, where it's going to preserve the white space. So us being able to put in special characters that normally wouldn't fit in a string, like a /n, is telling this string, hey, whenever you process this, whenever you parse this string in whatever format you want, I want it to show up with a new line, or I want it to show up with extra spaces. We also have a /t, right? /t is short for tab character, right? So this is a single tab right there, right? I'm pressing the arrow key once, and it's a tab, right? So that'd be the same as if I had hit tab on my, on a keyboard. So if we ever needed to include a tab for a paragraph, it's the /t thing, right? And if we went down to this one, right, our new line, I could do /t. So you see that when we call el.toString, this function, it's showing us that there was a new line and then a tab because I indented in. And you'll see a new line and then a tab. And then a new line and then a tab. So these are escaped special characters. Okay. If I went to el.string, right, let's see, 15, 16, where are we at here? O, what was the O? Oh, select or, maybe like 20. You'll notice that when we're looking at this character, /r is counted as one spot in our string. Same with, if we look at 19, or excuse me, 21, a new line is one single letter, even though it's 2 characters. Same with tab. So if we went to 22 now, right, that should be the tab spot, right? Tab. It's one spot in our string. Any questions about special characters or escaping characters? Go ahead.
So you were just counting the position that the characters were in the string, or was it an array created?
Yep. So every string is an array of characters.
Okay.
So it doesn't function quite 100% like an array does. Like we can't do, what was our my name? Was that? Let's see, bar my name equals Eric, right? So my name, 1 is the R letter. But I do not have the ability to do .push and put something on the end. Right? So it's kind of like an array because behind the scenes it really is an array, but JavaScript does not provide for us some of those functions that we use on arrays. Like there's no way to unshift or to shift. But we could, because JavaScript is infinitely flexible, we could write string.prototype type .push equals function, and let's put in another string here, and we can simply say return, or let's do this dot concat. Let's do this equals this dot concat string. Right. So we're saying the current value of the string, whatever string we're on, when we call push on it, it's going to take an argument of a string and say, hey, my new value is this concat string. Right. So if I was to save this code. Invalid. Oh, I can't do it like that. I got to do var new string equals this dot value of maybe. What is string dot prototype? String dot prototype. Shoot. Primitive value maybe. So the cool thing is that everything in JavaScript is infinitely flexible, so we can add new functions to primitive data types. With string, I would have to see value of that. It's a function. How do I set the value of string prototype? Oh, let's look this up. JavaScript set string value in string.prototype. I'd have to read through the documentation to figure out how to do this. But we could add that kind of functionality through the function, through being able to write our own functions if we wanted to include that kind of functionality in here. But we don't need it. Strings are simple enough that, for the most part, right, just behind the scenes, kind of sear into your memory that a string is just an array of characters, right? And so each index element has, right, my name equals Eric. Go ahead, Selena.
What is this? I looked it up and it still doesn't make sense.
Okay, so this is something we're going to learn about when we learn about when we learn about objects, and when we also learn about like true objects in the JavaScript context. It means, so like array prototype here. This is some magical thing that says an array exists, right? As soon as we create it, right? That is an array. Array has a whole bunch of functions in it, like concat, dot length. All these things exist because behind the scenes in the JavaScript engine, someone has written those functions in the prototype of that primitive, right? So array here is a class, right? Because we learned that we can say var teachers equals new array, right? When we say new array, we're saying create me a new instance of this class that has a prototype that includes all of those functions. When we are inside one of those functions, the way to reference the current version of the variable that we're talking about is with the special keyword this. So in this example, this equals the array we're in, or the object that we're in, right? We're saying, hey, every array has this function, right? And maybe we can show this off pretty simply. So we'll say array.prototype dot who am I?
So this is referencing the name of the whole thing that it's in.
It references the specific instance of that variable, right? So let's just do pick one, right? Say equals function. And so this function is going to exist on every array, and we'll say simply console.log this dot length minus one, or minus, yeah, one. That's fine. Okay, so every array will have this function included on it, and this is the current array that we're talking about whenever I call this function. So if I have an array and I say, Eric, Selena, Eric, right? Dot pick one, it's going to return, in this case, the last element every single time, this dot one. If I made a new array, right, and I said, Steve, now it's going to show out Steve. Right, so we're writing a function so that each of these arrays is completely unique. It's a brand new array every time. And if I did this on teachers, right, teachers is an array we already created. Dot pick one, it has that same function available to it because we added it to the array.prototype. But the problem is array.prototype is a class specific thing. So the only way to know which actual variable I'm talking about is to use the this keyword, which says whatever object I currently belong to. And we will cover this ad nauseum when we get into classes and when we get into objects later on this week and next week.
Okay.
But this is more advanced stuff for sure. Let's take this up. Good question. All right, where were we? Okay. Strings also have a whole bunch of other cool stuff. So var my name equals Eric, right? So we can do my name dot to uppercase, right? It's going to capitalize all the letters, right? It also has a to lowercase and lowercase all the letters. Any questions about that? It's pretty, for the most part, kind of self-explanatory. What if I had a string, right? My name. No, we haven't covered that yet. We'll cover that in a second. Any questions about that part of strings? Strings also have the same index of function that we had in arrays, right? So if I wanted to see my name, right, is Eric. If I wanted to see where is R in here, my name dot index of R, it's going to tell me it's in the first position. So if I was to say, what is in my name 1, we can see that it's R, right? We can also do RI, right? Where in this string does RI start, right? So RI starts in the first position. This is very useful because this index of contains the same, right? If we had a big long string like var long string equals I love bananas, they are delicious, right? I can do long string dot index of bananas. Like search for this string, tell me where bananas starts. Starts at position 7. So we were looking at el, right? Dot toString. I was kind of just hunting around to see if I could find the tab character, or was it 20? Yeah, or the character string. I could have simply just done, toString dot index of, give me the first /R. It's going to tell me the 20th spot. Index of here, right? If I type in banana, it's still going to start at 7 because banana starts at 7 as soon as it matches this string. But if I put apple, right? What do you think is going to come back as a value here? Oh, it shows it already. That's annoying. -1. Index of still returns -1 for any non-found strings. So you always have to check index of against the -1. It also has a long string dot char at b. Oh, char at takes a number, right? So I can say char at 5, char at 6, right? It is it is the same essentially as us writing long string 7 like that. You see how they both, the 7th position is the start of the word banana. It's telling you the character that is at position 7. They are it's literally doing the same thing. So either way you want to write it, if you want to write it as a function, great. If you want to write it as this, great. If we put in something that was, what's at position 10,000 or 1,000 here, undefined. If we use char at and we put 1,000, it gives us an empty string. So that's one of the major differences, is that this is going to return undefined. This is going to return an empty string. So that's really the only major difference between these two things, right? Char at, what else can we do with char at? Negative, -1. Yeah, perfect. Any questions with char at? Slice and split, right? So long string dot slice. If we put in, 7, 0. Oh, slice 7, 14. Yeah, perfect. So it works the same way as array for the most part. It's saying, show me the letters that are between the 7th spot and the 14th spot, right? So in this case, bananas. Bananas is a 7-letter long word. It lets us get that out of there. But you'll notice that slice, just like with arrays, is also safe to the variable, right? So long string still says, I love bananas. They are delicious. Everyone tracking? There is also a long string dot splice that has the same kind of, was there a splice? Let's check this. Might be thinking of something else. String dot splice. We would have to use something else. So what we would do in this case, right, if we wanted to splice in, do I cover this already? No, it includes. I don't cover it today. Well, let's cover it because it's fun. str replace string replace. Right, so in JavaScript, rather than having to use the splice thing that we were doing in arrays, right, we have a replace function that is way easier for us to work with. We don't have to worry about the position of these elements. So we can say string replace bananas with apples. Okay, and now long string still contains I love bananas, but the return of replace swapped out the word bananas with apples. So we could do something like long string equals long string dot replace bananas apples. There is no splice on the string in JavaScript. Any questions about that? We can also, right, long string is here, right? We have a function called split. Long string dot split. And what split does is it takes a letter or a word or anything we pass in here, and we can say, like for comma, for example, we can split on the comma and turn it into an array that is I love apples, they are delicious. If we were to run split with an empty string, it's going to break up every character literally into an array that is a JavaScript array. String.split with an empty string. If we put nothing in here, it's going to turn the entire thing into an array in the first element, right? So long string.split, the 0th element is the string. So if you want to split everything into letters, this comes up pretty often in like programming interview questions. They'll be like, you've got a big string. How would you turn it into, how would you swap out every letter A with the letter B, right? You can split it into a string like this using that and go letter by letter, swapping out letters. That's one way to do it. If you put a space in here, right? Long string dot split, space. Now it's going to be split up into words. These are all the words in this sentence. Split is extremely powerful. You will use split all the time because it lets you break things up in interesting ways. You can split literally on anything. You can say split on apples, right? I love something, comma, they are delicious. This would be one way to like find and replace, right? We could do long string dot split apples. Because this is now an array, I can use dot syntax here, and I can say dot splice 1, 0 vegetables. Right? And now if we look at long string, what did I do? Oh, because yes, that won't work. But being able to split strings like this is extremely powerful, and you will do this pretty frequently. Any questions about split? Cool. What else do we have to do on? Okay, and then the last one we're going to cover today is includes. Includes, right? And that's going to give you a true or false value. It's kind of like index of, right? So if we did index of apples, it's going to tell us the position of where apple starts. This is, in this case, 7. Includes is going to give us a true or false. So if I said bananas here, right, bananas, false. We will use includes pretty frequently in our Boolean, like in our if blocks, and when we're checking the Boolean stuff. So if I want to say like if long string dot includes bananas, like that, because that's a simple true or false, so that we don't have to you know, you like so. If long string includes bananas, console.log true bananas. Okay. That's not firing because bananas isn't in this string, right? If I change this to apples, let's make that apples, right? It's gonna echo. It's gonna console.log true bananas. If you recall, this was the example, right? Bananas. If I did index of here, index of bananas, right? That's true because bananas exist. But if I did index of apples, it would be true because the return of index of is -1. So the example that we talked about is like whenever you're checking that, you want to check for not equal -1. Is apples in long string? What is going on here? Long string. Oh. Excuse me. Bananas. Bananas. Does not equal -1. Okay? So includes is just a simple way to give you a true or false value that you can depend on. It makes your code a little cleaner so that you don't have to include this, you know, not equals -1 all over the place. If you're just searching to see does this string exist inside this other string, includes is a good choice. Cool. All right, it is 6:07. Let's take another break. Let's come back at 6:20. Cool. All right, the final thing we're going to take a look at tonight, we're going to spend quite a bit of time going over this because it's also incredibly important to understanding JavaScript as a language, is the concept of an object. We've been talking about objects in a bunch of different contexts. We've just been throwing the word around. But what is an object? At its core, an object is just a type of variable in JavaScript that can hold other variables, right? So it's just like an array in that sense, except objects can be a little bit more clever for us, right? So instead of with an array, right, these are all indexed by number, 0, 1, 2, 3, 4, 5 on down the line. In JavaScript, an object is, my object is defined with a squiggly brackets like this, curly brackets, instead of square brackets. And the squiggly brackets, the value in here, each of these rows is separated with a name and then the value, right? So first, Eric. Last, Harrison, right? And the key is always the first thing here, and it has a colon to separate the key from the value. Each one of these will have a comma at the end of it, just like an array, right? Because essentially it's like some programming languages will call this an associative array, where it's an array, but with instead of an index, it uses a key or a string as a key. Some programming languages call this a hash or a hash map sometimes, but they mean the same thing, that we use them in JavaScript as objects, right? So my object here is the name of this variable that is an object that has two values, first and last, and those values are the string Eric and Harrison, right? So if we were to pull this up in our browser now, clear, reload, good, take out this stuff. So if I do my object, right, it is an object that has a first and a last. And in JavaScript, we can reference these values two ways, right? We can do it the traditional regular array way with square brackets. We can say first, right? We can say last, or we can use the JavaScript notation where we separate these with a dot, right? We would say my object dot first, my object dot last, okay? We can also add new keys to our object at any time. Similarly, with the same type of way, we can say my obj, middle equals Ryan. Right? So now if we look at my obj, you'll notice that first, last, and middle, like they're in there in that order because that's how we put them in. But it doesn't necessarily have to be in any specific order. Whereas an index, an array is 0 through whatever. Objects don't have that kind of restriction in there, right? We can say my obj -1 equals family, right? And if we look at my obj now, -1 is a key at the end, And we can actually reference this now and say, -1 equals family. We can put in here my obj 4,000 and actually use a real number equals, tuba. And if we look at my obj, there is a key called 4,000 that has tuba, but you'll notice it didn't do what we did with arrays where it made 1,000 other, 3,996 other records. An object doesn't care about indexes. It cares about like the fact that you've got keys in here. And a key is another word for like the name of the placeholder for that variable. So if I did my obj.4000, right, that's going to tell us this is an error. Okay, and the reason it tells us an error is because when you're using a number, right, we learned this with variables, right, we can have a var age 2, right? The number can be in the variable name, right, like aha, right? But it cannot begin the variable name. I can't do, to age equals aha, right? It's going to say uncaught syntax error. So if you wanted to reference the number that we're using as a key here, you have to put it inside of here as a string, right? Each key in an object is a string. This is an extremely useful type of data structure. And all of the cool things we've been looking at up until now, behind the scenes, are objects, right? Because an object can contain functions. A function is a type of data that we have in JavaScript. So I can say full, right? Instead of typing in the string Eric Harrison, right? I could do function and have it return, return this dot first plus space plus this dot last, right? And if we call my obj dot full, the function, right, it's going to return the words Eric dot Harrison. So we were talking earlier about like what makes what is the this here? This is this specific instance of this object, right? If I made a second object, right? A second object here, my obj2, and I made this Meg Harrison, right? I can still use this same function, but now if I do my obj2 dot full, right, that function is going to return Meg dot Harrison because this refers to this specific object or this specific this variable, which is an object. Okay, all of JavaScript is built on this principle, right? When we were playing with document, right? For example, document is our HTML document itself. Document is an object that contains HTML nodes, right? If we open this up in our little console here, we can see that the actual HTML source code here is each individual element of this page. Document, right, has properties. It has functions. It has all of this stuff. The entirety of JavaScript is built on the concept of objects like this. When we were playing with our array, right, we said array.prototype. Array is an object, and we'll learn about the .prototype, like why that's really cool. But it's saying, hey, anytime there's an array, check to see if I type array.myconcat, it's looking in the prototype to say, is there a function or is there a property there, right? We can make an array.prototype real length and just make it equal to 89, right? So now if we reload this page and we look at teachers dot real length is always going to have the value 89 in it because the array prototype defined that there. All of JavaScript is built in the concept of we're going to make an object, or in this case a class, which is kind of showed up as green. We'll learn about classes later on, that have properties, have values, have functions, have methods, right? So when we're defining objects like this is the object literal syntax. We're saying, I'm going to create an object and assign it at the same time. We're saying my object is this. It has a property of first that has a string value of Eric, a property of last that has a string value of Harrison, and a property of full that is a function that returns this plus this first plus this last. An object can contain any type of variable that we've talked about to date and all the other ones we haven't. Okay? It can have numbers in here. Age, 37, right? It is a completely robust and amazing data type, right? Because I can make my object here have an age property, and this my object 2 down here does not have an age property. Doesn't matter. We can put whatever we want into these objects, and this is kind of the basis and foundation of all of programming. Okay. Specifically and especially in JavaScript. Go ahead, Selena.
Whenever you type it out, does it have to be on separate lines, or can they all be in one line?
Great question. It can all be on one line, right? First, right? Last. Age. Full. Like, all of the white space here is for our benefit, so it's easier to read. Right? If you wrote a bunch of code, like this is the simplest object you'll ever write in your whole life. You can imagine if you wrote a very complex object, right? And you're in here working and you want to go add a property, right? Like this is harder to read and work with. All of the white space, all of the new lines, all of the tabs and indentation is for our benefit, right? And you'll notice that I have this rule, and this is like my rule. Whenever I'm inside a block, like inside of one of these things, I'm always going to add at least one level of indentation. And so that's what the browser, this is what the editor does by default when I hit enter. It's giving us one level of indentation. And you'll notice when I get to full, this is a new block. This is for inside the function here. And so when I hit enter, it's indented here as well. And so I like to have my code neatly lined up like this so that I can see visually when I do something wrong. Right? This is one thing that helps me. Another thing that's important to note in objects, in object literals like this, just like with arrays, is that these commas are important. They separate the previous value from the next. And you can see as soon as I take out that comma, this full says it's got an expected comma, right? It knows there's a problem here, right? It's going to give you some kind of esoteric warning like this, unexpected identifier. And if you click on this, it's going to take us right to the line of code, and it's going to say, hey, this word is unexpected. Almost always the problem when this happens is that you're missing something right above it. Almost always. So that's letting us know that our comma is missing. Each of these has to be separated with commas. You do not have to put a comma at the end of your last element. In some languages, it's really nice to see that so that it's just a good rule to always follow, so you can come through and just anytime you add a new thing, you can say like middle Ryan. I would put a comment here. Older browsers, specifically old Internet Explorer browsers, would throw an error when you put a comma at the end. This is called a trailing comma, like trailing the end of the, like this is the last element. And so it's best practice to just not include it in JavaScript. So whatever your lowest element in the list is, don't put a comma in there. Modern browsers don't care. And so if I was to come in here and type, my obj, right, you can see that it included the middle object in here, the middle value correctly. But if I was using like Internet Explorer 6, for example, this would cause my code to break. And Internet Explorer 6 was such a bad browser, it would not even tell me that this was the problem. It was just one of those things you had to know. And it would bite you in the butt every single time. So just get, it's a good idea not to include a comma at the end. But every other element has to have a comma. Any questions about this specific syntax? This is the object literal syntax. You could have, right, because this object is declared with var, right, whenever we say var, we could have said, we could have written this entire thing this way. I'll just make it separate so we can see. I could have said var, my obj equals, right, like that. And then I could have gone line by line and said my obj first equals Isla, my obj last equals Harrison, my obj age equals, how old is she, 12? Yeah. My obj full equals function return this dot first plus this dot last, right? Let's make this 2, 3, keep them separated, right? So my obj now, the one we defined in that other pattern, right? It's just simpler to do it all in one swoop like this. This is cleaner looking code than doing it like this, where you're defining an empty object, then adding each property line by line. But you can in fact, do it this way. And the way we would sometimes do, sometimes what you'll do is you'll create a blank object like properties or something, and you'll say, hey, this is the thing, and then you'll be looping through, maybe some data set like var I equals 0, I is less than multi-dim dot length I plus plus, and you would maybe say properties I multi-dim I equals student, right? So if we run this code right now, we look at properties, right? It has created an object with the name from that multi-dimension array, and then the word student. Eric, Creef, Olivia, Josh, student. Eric, student. Selena, student, right? So sometimes you will write your objects this way when you're trying to do it through loops and through some more dynamic things. I just wanted to show off really that there's a bunch of different ways to create objects. There's a bunch of different ways to use objects. And when we start getting into more complicated programming styles like object-oriented programming, then we introduce classes, and we introduce the new keyword and the dot prototype thing that we're doing up here. That this is all magic stuff, right? This is what makes the language so cool for building web products with. Go ahead, Josh.
When you're writing these objects, or I imagine they're kind of like databases.
Mm-hmm.
Are these just thousands upon thousands of lines of code? Because I assume it's, if you're doing something like your example, say we're doing it for I don't know, clients or something like that, and you have 1,000 clients, so there's got to be a ton of code on there. So how do you write that all out, or is there a way to condense it to look at it and sort through all this?
Yeah, good question.
You have to write it out manually.
So generally, whenever you're working on a real project that has any kind of, you're doing anything significant, it's going to be thousands, if not tens of thousands, or in some cases hundreds of thousands of lines of code. But generally, you're not creating these objects yourself. You're building a product that will have a form so that users can go in and type in some information, they click the save button, it stores it to a database. Your code, which will end up being 10 or 15 lines of code, will pull all of those records from a database and store them in an object so that you can loop through that object. We're going to learn about loops and conditionals and if statements and stuff tomorrow, which is really the glue that brings all this together. Very rarely will you go in and manually type out a giant object full of records. The object is going to be, the records are going to be stored in a database or in a file or someplace on the internet, some other place. You just have to know how those objects are, how to work with those objects so you can loop through them, you can get the information out of them, you can manipulate them, submit changes back to a database. That's the fun part of programming. You will have thousands of lines of code. No, there's no question about that. Anything worth building is going to be pretty big. But you won't be doing thousands of lines of typing in, hopefully, actual data structures. Good question. This DB records, I wouldn't type this all out to have every time I needed to add a new user, I wouldn't add a new line in here in my code. I would put it in the database, and now the database is storing it, and they're worried about it, and I just have to say, give me the DB records. So I'll have some, in between here, I'll have some kind of, DB records equals database.query, users, right? Something like that. And it will return every one of those records. And this is fake code, obviously, but that's a more realistic way that you'll write code. Then you'll write your loop to go through it and actually display it onto the page and stuff like that. But you haven't had to type out all of those objects and stuff. Perfect. Cool. Any questions with the object? Right? We talked about the dot syntax versus the object syntax, or the array traditional syntax here. This is safer for when you have keys that are maybe made up of numbers or made up of weird things, like the example that we used of -1 or 4,000, right? Because all of these keys are strings, if you try to use the dot syntax, it will throw errors. If you did, my name, right? So if you do my obj dot, let's let's do negative 4,000. Right. Oh, I should have made it equal something. My object was right. My object. If we look at it, right, we can see that key is in there. If we reference it with negative 4,000 in this like array bracket type syntax, it works perfectly. If we were to try and type that out in dot syntax, right, JavaScript doesn't know what to do with this because this is invalid syntax because this is trying to like do math operations on a dot, which is incorrect. So the square bracket syntax is always safer, but you'll notice even in like a document.getElement by ID, right? The document object has a function called getElement by ID defined inside of there. We're using the dot syntax here to make it look better. I could have written it like this, right? Oops, square bracket, and then put in what do we have? Header, right? It's doing the exact same thing inside the browser, like all these browser-specific functions. It's just an object. Right, that's the exact same as getElement by ID that way. Cool. All right. Other stuff that we can do with object, and these are really more useful for debugging. Every once in a while, you'll need this for a specific, like, give me all your keys or something. Any one of these objects, right? My object. We have a couple of specific functions. One is object.keys, and we can put in my object, and it's going to give us an array of all the keys, right? So first, last, age, full, negative 4,000. There is another function. There's another method in the object thing that is myObj.values, and it's going to give us just the values. Isla Harrison 12 function ha. Object.keys, object.values. If you ever needed to be able to iterate over, right, an object on all of its different properties, like you could do it with this way, right? Because we could say something like for var I equals 0, I is less than object.keys my object, right? I plus plus. And then we could say console.log my object. What are we doing? My object. Wait. Excuse me. Yep. And then where's object keys? Oh, dot length. What am I doing? Dot length. What do you do? Object dot keys. My object. Perfect. Right. So that's gonna print out, first, last, age, full, negative 4,000. Like, these are really useful sometimes, and the times when they come up, you'll be like, how do I get all the keys out of this object that is created? Because each one of these objects is different, right? So we can do object.keys document, right? And it's gonna give us location. And we can do object.keys my obj2, right? First, last, age, full, middle. Sometimes that's useful. It's really good for debugging. And every once in a while, you'll come across a problem where you're like, I need to get each and every property out of this object, and I don't even know what properties are in there, right? Because they're not indexed, right? It doesn't go from 0 to some dot length, right? There's no myObj dot length because that has not been defined. So that is, this is often the only way to figure out like how many records are actually in this object, is to get like the keys. Because object.keys is an array, right? Object.keys, myObj.length. Right? There are 5 records in this object. Then object.entries is another interesting one, which breaks up each and every one of these values into an array of arrays, right? A multidimensional array where it says first and then the value, last and then the value, right? Key and then the value. So if you ever wanted to see, if you ever needed this to be an array for whatever reason, right? Object.entries is pretty much a combination of smushing together the return of object.keys and object.values. And you'll notice if we type in object.entries, right? If we look at number 3, right? It's preserving the fact that this is a function. So I could have said object.entries, what is it? My obj, right? And then I could say 3.1, which is the function, and I can call it, and you'll notice now that it says undefined, undefined, because this is a keyword specific to the object that it belongs in. And the object that this belongs in, 3.1, is the array number 3, which has no name and has no value, first and a last property. So this keyword has followed this around, even though it has left the context of being in that object. And now it is throwing undefined, undefined, because if we do .toString, it's trying to return this dot first and this dot last, when this is actually a pointer to my object 3.1, which is an array element, right? There's no this, or there's no first and there's no last in there. There's a lot of really cool stuff that you'll start to discover the more you play with this language. That is really exciting and very interesting. Has own property. Has own property is a really cool way to check and see if a key exists specific to that object, right? So has own property, if I type in first, right, there is a key called first. Let's maybe show this off with the teachers. Has own property. Right? If we put in the word, what did we call it? My concat. It does not have. Did we rename it? Yeah. When we're talking about objects, sometimes when we get into more advanced concepts in the programming side of things, when we start learning about dot prototypes and stuff, we want to know if a value exists as a part of the object itself, in this case like the first name, or if it's coming to us from a outside source like the dot prototype thing, right? So if we were building an object, so if we said, here, let's maybe make an example here. Object dot prototype dot fun name equals erock, right? So now literally every object in the entire app, right, even document dot fun name, right? Document dot fun name is Eric. My obj dot fun name is Eric, even though fun name does not exist in my obj, right? It's because we put it in the prototype. So what we would sometimes need to check is if my obj dot has own property fun name is false, because that property is coming from the prototype. It's coming from outside of itself. So this is one safe way to check to see if, when we're talking about objects as a data storage device, when we're saying all of my user records are stored in this user object, we need to know if first is coming from the object itself or is coming from some function or some library outside of itself. Has own property lets us check that. Okay? Has own property will be false, even if it, right, my object does have a property called fun name, but it does not belong to my object. It belongs to all objects. Any questions about that? We're introducing this like blow your mind concept right now. You're going to use it for the next 4 weeks, and we're going to dive in super deep on classes and object-oriented programming, I think next week or the week after. And this is like fundamental to building libraries and building really, really cool, performant web applications. So I'm just introducing it now so that in a week, you're going to be like, oh yeah, we talked about that. Go ahead, Josh.
I'm having a hard time looking up has own property on W3 schools.
Okay.
I don't know what I'm.
Let's check this out. Has own property. Yeah, W3 schools might be a bad place because you'll notice even here, like they're using Google search. They might not have a whole page on has own property because W3 schools is talking about the language of JavaScript. And the context of has own property is a DOM specific, a browser specific thing here. So let's just look at Google has own property, and I bet you Mozilla probably Mozilla has a really good definition of this. And what it's doing is it's saying, okay, so they're even telling us that there's a better version of this now called has own that is recommended over has own property. I don't know. But they give a few pretty good examples here. Mozilla's documentation is excellent. W3 Schools documentation is excellent. Generally, why I prefer W3 Schools over Mozilla. Mozilla's got the better documentation by far, but W3 Schools has the better like interactive examples. So they'll give you like, hey, we're talking about this one specific thing. Here is 8 lines of code that show you how to use it. Mozilla has a few of these as well, but like they don't always have like that interactive try this and change it and see what it is. They just kind of expect you to copy it and paste it in your code, try it yourself. So they're both great resources.
Okay.
Cool. Any questions about that? Anything about that we've talked about today? We really focused on the basics of like every program you're ever going to write from here on out is going to use strings, objects, and arrays. That's the building block of all programming. Okay, and primarily, I mean, the big thing to focus on today is arrays and objects because that's the data model is the big thing here. A string. One of the reasons we focused on string today is to show off that there's a lot of things you can do in arrays that you can do in strings because behind the scenes, a string is really an array of characters. When I first started programming, I went like I was in high school. I'd been programming for several years since then, but I first learned C++, and in C++, that's the first thing that they start to teach you is like if you want a string, it's an array of characters, and it was very difficult for me to wrap my head around that idea because strings are inherently difficult for computers to deal with. Computers are great with numbers, but as soon as you start bringing in, words and things, it gets challenging. Any questions? All right. It is 6:52. Let's take one final break, come back at like 7:05, and we will have another quiz based on the stuff we covered today for everybody to do. Well, that was a lot of fun yesterday, and we'll take that quiz and go over the answers together. All right?